In this episode, we're going to look at a new PHP testing framework called Pest. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this video, we're going to look at Pest. This is an alternative testing framework to PHPUnit. Whereas PHPUnit is an XUnit style testing framework, Pest takes a Spec style testing approach. One of the advantages of this is it allows you to be more verbose with the introduction to your test by allowing you to provide a string rather than just a test function name. In this video, we're going to implement a set class. The properties of a set will be that it holds unique values. So if you imagine our set as a magic bag, if we put in 2 blue balls and 1 red ball, the set would contain 1 red ball and 1 blue ball because the duplicate values should be removed as they're added. Let's look at the code. I have my IDE set up with my test code on the left-hand side of the screen and the implementation code sitting on the right-hand side of the screen. So you should be able to see both test and implementation all at the same time. The first difference you can see between a PHPUnit test file is that Pest doesn't require a class to be set up. So we just on the left hand side have a blank PHP file, and on the right hand side we have a class already set up but with no implementation. The first piece of functionality I want to add to my set is it should know whether it is empty or not. So we will add a test for a set that is empty. So starting on the left hand side of the screen, we're going to create our first test. So let's look at the structure of a test in Pest. So, test. So first argument is a string. So we'll just leave a blank string for now. And the second argument is a closure. So we'll add a function like so. And semicolon. So we're going to add the description of our test first. The first piece of functionality we want to test is that an empty set knows that it is empty. So we can think about the description of our test, and we could go with test that empty is empty. Okay, so that's the name of our test. We can always go back and improve it if we think that'd be better. We can think of something better, but for now that will do. So we'll create an instance of a set. So we'll call it empty. So we've been really clear with our variable naming. Equals new set. And now we want to make our assertion. So like with PHPUnit, PHP Spec has this, and we can use assert true. So we want that empty is empty. Okay, we can run our test here. And the test is failing because it's not found the set class. Okay, let's import class, that one. There we go, and we'll go back and try again. Okay, the test is still failing. So it's now saying that the isEmpty function is an undefined method. So we're going to solve that problem next. So our IDE help us, add method. Okay. So we run our test again. And it's still failing. So it's asserting that null should be true. So we can look at the simplest way to solve this at this point is to just return true. So if we run our test now, hopefully it should pass. Okay, so our first test is passing. So we're testing that empty is empty. Okay, so we're going to move on to our second test now. So now we want to check that if we add something to our set, then it thinks it's not empty. For the first test, we use the test function. So here it's test. But Pest also has another function, which is it. And it has exactly the same interface as test. So it still takes a description and a function for the second argument. So it maybe allows you to be more expressive. So instead of thinking that your test description will be test something, you can be more descriptive. So you can say like, it is not empty once something has been added. So I quite like the it over the test personally, because I think it makes you think more and be more expressive about what you're testing, the behavior you're looking for. Whereas I suppose maybe it's my mind coming from more XUnit. When I see the word test, I'm trying to be quite, I'm not being as verbose with my description. So if we go back and change the test above to say it, now I can say it is empty when nothing has been added. Here we go. Okay, so I think kind of that I personally prefer using the it function because it makes me more expressive and make me think slightly more about the behavior of my functionality. So now we've changed those two tests, let's start setting up the second test. So we need a instance of a set, so 1 equals new set. We need to add something to it as the test describes, so 1 dot add. Okay, so I said a set can contain anything. We're going to keep things nice and simple today and keep it short. Our set will be a string set, so it will hold unique strings. So we can add red to our set. And now we need to move on to our assertion. In the previous test, we used this assert, which is kind of exactly the same way that you can do assertions in PHPUnit and most XUnit style testing frameworks. But again, Pest offers us something different at this point. We can use something more expressive language. So we can say we expect 1 dot is empty to be true, like so. So again, it's kind of enabling a more expressive language around the behavior you're expecting, kind of making your test maybe slightly easier to read, or more natural to read is probably a better way of putting it. Now we know we're going to get a test failure because our IDE is telling us we don't have an add function, so we'll allow our IDE to highlight that problem and add the method for us. So it's public function, and I don't quite like this, so let's call this value. Now we'll run our test. Okay. Hang on. So this is my bad. There's a bug in my test. So this is why you always run your test first. Okay, so I was expecting a failure. I should see my test failure because I've added a new test, so there should be a failure. So I've made a mistake, and it's the simple one. I wasn't concentrating. It shouldn't be true. It should be false once you've added something. There we are. So we'll run that. And now we have a test failure. So let's look at that. Asserting that true is false. Well, it's quite obvious what's going on. Over here we've hard coded to return true. So it will always return true, but we're expecting false. And again, we're looking for the quickest, most straightforward way to fix the problem. So what we know at the moment is if we have a set and we don't add anything to it, it should return isEmpty will be true. And if we have a set where we call the add function, isEmpty should be false. So the quickest way to do this at this point would be to use a field in the set class that just holds the state of emptiness. So we can do that quite quickly. So we'll go private, we'll call it isEmpty, and that will be true when it's constructed. We'll do that quickly, default it here rather than using constructor. And then what we can do here is when add is called, we can do this isEmpty equals false, and we can then return the isEmpty field value. So hopefully that will solve our problem, and both our tests will continue to pass. And both our tests are now passing. Brilliant. Now's an opportunity to do some refactoring. We have green tests, and one of the refactorings I want to do in my test at the moment is to continue to use the expect rather than the assert kind of style of checking the result of my test. So we'll change this from assert true to expect $empty isEmpty to be true. There we have it. Okay. So we'll run our test again. We've made a change to the code, so we want to see that our changes haven't broken anything. They haven't. Okay. And now I'm going to look over at the code. The functionality doesn't do much at the moment, so there's no opportunity to do any tidy up. So I will leave that as is, and we can move on to our third test. At this point, we've probably exhausted our ability to test the isEmpty function. There's not much we can do more than have something in the set and it return that it's not empty, and have nothing in the set and return that it is empty. So we're going to move on now to looking at the size of our set. Okay, so it has a size of 0 when nothing has been added. Okay. So we need a set with the size of 0. So what we'll do is we'll copy down we'll copy down empty. Now we expect $empty size to be, now got to be 1, is there 0? So there isn't a 0 I can see. So instead of that, we can just use to be, and we can pass a value. So we expect size to be 0, like that. So we know our IDE is already telling us that the size function doesn't exist. So we can add the method, and if we run the test, okay, test is failing, surprisingly. So we have failed with assertion that null should be identical to 0. It's not. Okay. So going back to our previous implementation, we know that the quickest way to solve this problem at the moment will be to just return hard-coded 0 in our size function. So we'll do that. Return 0. So save. Let's run that test. Test has passed. So we can move on now to our next test. So we can do it. Cool. That saves us some typing, doesn't it? Has a size of 1 when nothing, when a thing has been added. Okay, there we go. So again, we can take our copy and paste the stuff from our not empty test. And so we expect one size to be 1. Yeah. We'll run our test. So it's failed on our last test. Failed asserting that 0 is identical to 1, which is not a surprise given we have hard-coded the value 0 over here. What's the easiest way to solve this at this point? At the moment we have the isEmpty field, which says true or false. So could we just say, so if we cast it to an int of not, follow this isEmpty, that work? So yeah, that should return 0 or 1 at this point, I think. It does. There we are. So we obviously still haven't solved the problem, so we're going to go back and write another test to force us to make a better attempt at implementing the final implementation of the size function. So it has a size of 2 when 2 things have been added. Yeah. So we'll take our copy and paste again. The size, so we'll just refactor there. 2. Nice. Okay, so it won't be 1 this time, it should be 2b. I'm guessing there's not a 2, so we'll just use the 2b function and pass 2 in. There we are. Okay, we'll run our tests again. One thing I haven't shown you yet about Spec is its output. We were just using the IDE to jump directly to the errors, but it actually gives you quite a nice output as well. So it gives you, so you can see that the class that's being run, and then you actually get an output of the expectation. So it is empty when nothing has been added. It is not empty once something has been added. So that kind of the level of description you give really helps you to kind of read and understand the behavior of whatever you're implementing, because it's printed out on the screen, and you can see obviously the green ticks where it's passing and red crosses where it's failing at the moment. But I kind of really like this approach because it gives you a nice kind of description of how a class, or the description of the expected behavior of a class. Whereas kind of other testing frameworks, or an XUnit style of testing, doesn't give you that. Maybe it just gives you the test function, but the test function obviously is in just camel case, so it's quite hard to read. Whereas this makes it really nice and readable to what's going on. So if you were working with product owners or kind of non-technical people, they can still see the expected behavior because it's kind of written out in nice, clear, easy to read, plain English. We've gone through that output. Now let's go and solve our failure. So we were expecting 2, but we got 1. So we need to look at how we can solve this. I think at this point we've kind of exhausted using any of the fields and information we have within the set class, because at the moment all we know is whether it's empty or not. So if it's empty, it would be 0, and if it's not empty, it would be 1 or more at this point. So we need to start tracking the size, the number of things that are added to our set. At this point, we'll add a new field, so private, and we'll call it size equals 0, so starts at 0, and we can call this size, and we can increment that every time we come through the add function. And then instead of returning is empty, we can return this size. Okay. We'll run our tests. Oh. 1 is identical to 2. Ah, okay. So again, I've rushed ahead a bit and I've made a mistake. I only added one thing to our 2 set. Let's fix that. So that should be blue. Okay. And we're back to running the test. And now it passes. So that was bad of me. I should have been better at looking at the output of the failing test to see that I had a mistake in the test. Sometimes that sort of thing's going to happen though. We now have the size function fully implemented. I can't think of any tests to add to exercise the behavior of the size function other than checking empty is 0. 1 got me halfway. I was checking whether it was empty or not, and returning basically a flipped integer of the isEmpty field. But then the third test on size, got me there. I had to implement something that really did keep track of the size. And I don't think adding another test around the size function would move the functionality on any further. So at this point, we finished testing the behavior of the size function. So this is a good opportunity now to look at refactoring. Refactoring is the time when you want to spend tidying up the internals of the set class or whatever you're implementing. It's a time to tidy up the internals, but so this is not a time to be making changes to the interface, because the only time you make changes to the interface of the class will be during the testing phase, because the test will be telling you what should be changing externally. But we can make changes to the behavior, how it works internally, without affecting the external behavior. And a really good example of this at the moment is we've got this isEmpty field and we've got the size field. These keep some internal knowledge about what's been going on in the object. But there is also duplication of that knowledge, because we know that if the size is 0, then the set is empty. So we don't need to keep both fields at this point. We can remove the isEmpty field. It's become redundant because of our knowledge that size being 0 means empty. So we can change the isEmpty function to say return this size equals be really good, 0. So we know at this point that if the size is 0, empty will return. So we can also now remove the field, and we can remove flipping the field in the add function. So we've actually removed quite a few lines of code from our set class, so it's become smaller. It has less cognitive load to understand what's going on internally, because we only have one field, and we can see that the field is used here to work out whether it's empty. Here we increment it because we're adding things to our set, and here we can use it to return the size of the set. Okay, so that's probably all of the refactoring at this point we could do on our set class. But refactoring doesn't have to just be the implementation side. We also want to keep our test side of life as tidy as possible as well. Now, during the writing of the test phase, I did quite a lot of copying and pasting, And that's a really good indicator there's probably some tidying up I can do within my test file. So I copied empty set from the first test down to the third test, and I copied one set from the second test to the fourth test. So there's two pieces of completely duplicate code in this test class, which we could look at removing and improving. The readability of our tests. So we can use something called a before function or a setup function. These functions get called before each test is run, and allow you to get things into a state ready for testing. Given we copied and pasted the empty set variable and the one set variable, this seems like a really good opportunity to use the setup functionality so that they are instantiated before each test runs. It's quite nice to have your setup functionality at the top of your class. And what we'll do is setup function in Pest is called before. So you've got before all and you've got before each. Before all runs once at the start of the testing of a file. So if we use before all, it would happen once. If we use before each, it will be called before each test in the file is run. So we'll use before each for now. That takes a function. Okay. Now, we need some variables to set, so we can say $. Well, let's see what happens if we just pull this up. What we can do is, instead of using the local variable, we can assign it to this. So this empty equals new set. And then when we assert, we say this empty is empty, like that. Okay. And if we do the same for the one, so we take this up, and okay. So the one, this one. Okay. So those tests are now very small and very clear what's being tested. Not much to read. And because of the naming of the variables we've used, so empty is empty to be true and one is empty to be false, it makes the test very easy to read, very quick to read, and very clear what's the intent of the tests are. So we can now remove this line, this empty, and we can remove these lines, this, and one. There we are. So we've made those refactors. So again, we need to run our tests. Tests are still passing, so we're happy to continue. So you can see that our tests have got very small. So we can move on. At this point, we're not yet using the contains function, the to function. What we're going to do with this is not refactor it. We will leave the to set alone because there's no duplication, so it can just sit here like this. It's fine. Okay. We're now moving on to some more functionality. We want to know whether our set contains a given value. Start with the it function. So it contains red if it, or it has to start with the opposite, it doesn't contain, so it does not contain red if red has not been added. so. Now we need a set where red has not been added. The empty set is perfect for this. So we will call, we will expect that $empty contains red to be false. $x this. We are. Okay. Okay, so our IDE tells us that we should have. There we are. Okay. So we can run this. So at the moment, well, our IDE is not telling us that we need a contains function, but we know we need to. So we're not going to watch that failure. We'll just add that quickly. Public function contains that has a string $value. Okay, there we go. So now we'll run our tests. It's failing. So we're asserting that null should be false. Okay. Like with all of our other tests, the quickest way to solve the failure will be to return a hard-coded value, and in this case it's false. And if we run our test now, our test is not failing, it's passing. So we're now in a position to move on. It does contain red if red has been added. And again, we now have a set that does already contain red, so our test can still remain nice and short. We can go expect this 1 contains red to be true. Add semicolon. Let's run the test. Ensure it fails. It does. We've seen it fail. It failed how we expect. We made that mistake, so asserting that false is true. We've set up our test correctly, so now it's time to move over to our implementation. At this point, I could use emptiness to check whether the set contains red or does not, because we know that if the set is empty, it doesn't contain red. If it is not empty, it does contain red. But what we're going to do is going to go straight into the implementation now. Okay. For this, I'm going to just use a plain old array to store our values. So this is a point where we're actually going to start storing the values and really kind of implement the core and the real functionality of a set. So we go private $values equals empty array. Okay, save that. How can we implement it? So we can do this. So for each $v. Do you know what? I haven't written. Okay. So I haven't written PHP for each in a while, turns out, and I've forgotten how to do it, so I've just Googled it, and it's for each $this values, with value, that's not very good, should be values, we'll refactor that now, values as $v. If $v equals $value, return true. Brackets. And align all that nicely. There we are. Save. Okay. So we'll run that. So it's still failing, and that's because I made a very simple mistake. I forgot to add anything to our array. So this values equals $value. Okay. We'll run our test. String given. Mistake. Brackets. There we are. There we go. Our test is passing at this point, with a bit of Googling how to use a for each. So at this point, we could look at doing some more refactoring. Now, because of the way PHP arrays work, we could just do, instead of using the size field, we can get rid of that now. Use len. Count the $this values. So if the values equals that, and we can just use a count of values. Let's see if that refactor has worked. It has, so we can now do some tidying up. So we don't need to keep track of the size, because we can do that from the array. We don't need to increment the size. There we go. So we can run that. And there we have it. Our set now knows whether it contains a value or not. So now we can move on to testing the final piece of functionality of our set. So I said at the beginning, a set should hold unique values. It should not contain duplicates. So we need to ensure that we can't add duplicates to our set. So we'll create another it. Say, so it does not save, store duplicates values. Okay. How can we test this functionality? Because we don't want, can't spell still can't spell. It's okay, the IDE can spell for me. Okay. Because we don't want to add new external function to do this for us, or check that there's duplicates added. We just want to, when we add something that is a duplicate, we want the function of add to ignore and not store the duplicate value. What we can do with this is we can use some of the existing functions to ensure that duplicates aren't added. The first thing we can do is attempt to add a second red value to our one instance. So the one add red. We know it contains red. And the easiest way we can check whether the duplicate red is added or not is we can check the size. We know that the size should be 1, and after we add a duplicate value, it should remain at 1. So we can expect this one size to be 1. So if we run our test, we should get a failure, and we did get a failure. And we failed asserting that 2 is identical to 1. Perfect. Our test is valid. We're testing the right thing. We should be getting 1, but we got 2. So now we can move over to implementing the functionality. We want this functionality to be in our add function, so we don't want duplicates to be added. And what we can do for this is we can check. So if does not contain the incoming value, then we add the value to our internal array of values. Run, and that test passes. Now's an opportunity to do some more refactoring. One of the things I personally don't like is the big if around the entire function. And also, I find that using not too much could also make the code slightly more difficult to read. You have to there's that extra step of thinking. So instead of having checking the opposite value, the opposite of contains, using the not at the beginning, what I'm going to do is use something called a guard statement. So I'm going to take off the not, and I'm going to say, if this contains the given value, then you early return. Like so. But if not, you continue to add the given value to your values array. So that's a guard statement at the top. It's kind of more, the idea is you protect your functionality by checking for invalid cases early and getting out of the function rather than continuing through to the end. Okay, we'll run our tests again. And our tests are passing. That's the end of the video. We've now fully implemented our set class. We have a very nice, tidy set of tests that are nice and explicit in the expected behavior of a set. We have a nice small implementation of our set class, which is very straightforward to read. I hope you enjoyed this video and go and play with Pest. I highly recommend playing with it. If you're coming from XUnit kind of style of writing tests, it does take a little bit of practice to get used to kind of that more explicit, the kind of being as explicit as you are and as verbose with the description. So with XUnit, you're trying to keep those function names as short as possible, whereas with the description in the it function, you're looking at being more verbose. If you're coming from BDD and using bhat, then kind of this verbosity in the description you'll be used to anyway. I hope you enjoy playing with Pest. If you have any questions or you want me to try out any other things with this testing framework, then just reach out with a comment at the end of the video, or you could tweet me and I'll try and do some more Pest videos soon. That's all for now. Cheers. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Braddle.